It's actually quite interesting following the BDD talk. I call this TDD demo. I think probably a better name is acceptance testing, the good, the bad, and the ugly. What I was just going to do is do a quick run through of the way that we do acceptance testing where I work. It's quite interesting. When I arrived at the company, it's the first place I'd really taken acceptance testing seriously. I'd like to claim some credit for any of this, but it was all there before I started. So it's, other people have done this smart stuff before me. So the way we generally start, we have a story. In this case, we have a story called a mean stop loss price. So we create a test called the mean stop loss price acceptance test. So we've got a one-to-one mapping of acceptance test to story. It's great because if you know what story you're working on, you know where your test is. It's bad because if you're working on a story that may impact functionality elsewhere, sometimes it can be difficult to find the acceptance test you're likely to break. Chances are you've got to wait for it to run through continuous integration to find the failures. First thing we do is generally use a fairly standard setup method. One of the approaches we take is to create all the data we need ahead of time. So in this case, we're creating instruments and we're creating users. This is really great because it gives you data independence for every test and keeps things separate. It's bad because it does slow your tests down. It does put fairly uncommon loads on the build system. So the test I'm going to demo, we've taken this approach of actually trying to make things look a little bit like English. So we have a sort of a DSL. It's probably a bit of a glorified term for it. It's basically just a set of vararg strings which look like name value pairs. It gives us basically name to default parameters. If I was to do this again, I'd probably redo it at scale. But the idea is it should read roughly like English. So in this case, I'm placing a mass order, I'm putting some liquidity into the market. I'm placing a normal order, and then the key thing I'm looking to do is click a button, put a mean stop loss price, set the value to minus 1.2, check the calculated value after that, and make sure there's no error messages popping up. And the name of my test explicitly relates to the acceptance test criteria. So I'm saying check that a stop loss offset can be negative, and that's this particular value here. So all of this stuff runs on top of Selenium for all of our UI tests. And one of the key things we found with Selenium is it's very easy to write brittle tests. And the way we got around this is that we don't write tests to Selenium directly. We always go through a layer of indirection. We call that a driver. So when we have a component, from this case, our mean stop loss price dialog, there's a driver for that that knows the internals of that particular dialog. It knows what the component IDs are. And we put some methods on top of that that express the features of that particular dialog. For example, enter an offset, calculate the stop block value, check values on the particular thing. So if the structure of the component changes, we just change the driver, and we don't need to change the acceptance tests. So I'm just going to run this test as a bit of a demo. It shows you running in Selenium. It's going to do a bit of setup first, so I'll take a little while to kick off. So basically just logs in. Passes. And our bar goes green up there. That's already run great. One of the key things that's missing from this is tests are really useless unless they run all the time. So, in addition to having this acceptance test framework, we've put a lot of effort into building a fairly comprehensive continuous integration environment. And this is basically a screen that sits above all the developers in our team, and it gives us an idea of what tests are running there. Ooh, the hot's horrible there. So just to give you an idea of what this does, the one at the very top is the commit build. So when you check in, every commit that goes in gets run through that build. If that thing goes red at any point in time, the person who made that commit's got 10 minutes. And they've got to either fix it in 10 minutes or roll it back. So that's basically stop the world. We've got to the point where we actually find people who don't roll changes back within 10 minutes. You have a little pot on the desk and we drop coins in it. And if you check in on a broken build, you also have to pay a fine. The really interesting one of these is actually master. This doesn't run any tests per se. This is basically an automated deployment to a single instance. And then the boxes from API 1 through down to QA defects are all running tests against the same system. And this is really useful for actually putting real heavy load onto the system. It's really useful for finding concurrency bugs. Because each one of those boxes is running 4 threads with a session in it. So we're running about 120 concurrent sessions onto our system every time we do a build, or every time we run a build through our test environment. I've got 10 seconds left, so I'm going to stop there.